Okay, so today we are going to cover irrational square roots. And what I mean by that are these are going to be not perfect squares. So in the previous two lessons, they were all perfect squares where you could find a whole number times itself that would give you the answer. So our objective here is to simplify radicals and to find decimal approximation of irrational square roots. All right, so let's go ahead and take a look at our first example. Now, this one actually is a perfect square. However, the number's kind of large. So possibly at first glance, you might think, oh, it's not a perfect square. So what you're going to do is you're going to do like a factor tree. Now, there's actually two ways you could go about doing this. You could either keep breaking it down and do the whole factor tree until you get prime numbers, or you could look for the greatest perfect square that'll divide into it. I'm going to go ahead and completely factor this and keep breaking it down. So I'm going to look for two numbers that will multiply to give me 324. Now obviously you can see that it's even, so we could actually divide it by 2. So let's go ahead and let me do that up here. 324 divided by 2. 2 goes in here once, 12, 6, and then 2 goes into 4. So 162. Now, if you realize that there were a larger number, like say 9, because you could use your divisibility rules where you could add the numbers 3 plus 2 plus 4, and notice that that would add up to be a 9. So I know 9 will go into there. However, if you're not good with those divisibility rules, then you're just going to find a number that'll divide in there evenly, and then keep breaking it down until the whole thing is prime. So 2 is prime. I'm going to keep breaking it down. Now, notice this has a radical. So each one of these factors is still under the square root symbol. Same thing here. I could divide this by 2 again, and I could get 81. The 2's prime, so I would keep breaking them down or bringing them down. And then if you realized 81 was a perfect square, you could square root it right then and there. But I'm going to keep breaking it down until I finally get prime numbers. So 9 times 9 is 81. And then keep breaking it down. 9's still not prime. And break both of those 9's into 3's and 3's. So now I have a bunch of prime numbers, and again, I want to make pairs of these. So what I'm going to do is pair them up. Once I make pairs, this becomes a perfect square. And anytime you multiply a radical times itself, what'll end up happening, or a square root times itself, the whole number comes out. So the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So you really don't even need to think about multiplying those back. Just know that when you can make a pair of 2 square roots, that the whole number, the radical will go away, the radical symbol. So what I'm going to pull out of this is a 2 from this one, a 3 from this one, and a 3 from this one. And then I'm going to multiply the numbers. So 2 times 3 is 6, times 3 is 18. So the square root of 324 is 18. So again, this one was not irrational, it was rational, it was a perfect square. Now, the last 3 here, B, C, and D, these are going to be irrational. And let's go ahead and see how we're going to solve these. So 75, again, think of 2 numbers that will multiply to give you 75. Now, I could do 3 and 25, and that would go right to a perfect square. And if you were good at recognizing perfect squares, you could just square root the 25 and the 3. But let's say you didn't start with that. Let's say you started with 5 times 15. It still works. So we would bring down the 5, break down the 15, and notice I make a pair of 5s. So one of them comes out, and the 3 that doesn't pair up stays underneath. Either way, I got the same answer. Let's look at letter C. Again, 112 is not a perfect square, so I need to break that down. So 112, and I also have a 2 outside of the square root symbol also, and that's just going to sit there. So I'm going to go ahead, bring down that. I'm going to start my branches here, and I'm going to divide. I can see that I could probably divide it by 2 because it's an even number. So 112 divided by 2. 2 will go into 11 5 times. And then 2 will go into 12 6. So 2 times 56. Now, these are still under radicals. This 2 on the outside is already free. He's out. Now, I need to break down. So this guy keeps coming down. Same thing with the 2 under the radical because he's prime. And then now I need to branch the 56. 56, I could break that into 7 times 8. I'm still not at prime numbers. The 7 is. So keep bringing the 2 down. The square root of 2. I can also bring down the square root of 7. And then I need to still branch and break the 8. 4 times 2. And now I still have one more step because my 4 here is not prime. So this guy keeps coming down. The 7 comes down. The 4 goes to a 2 and a 2. And then this radical 2 comes down also. So now I'm going to look for pairs. So I have a pair of 2's here and a pair of 2's here. So out of this pair, a 2 comes out. This 2's coming straight down. Out of this pair, I can also bring out a 2. And then the 7 stays underneath. Everything that comes out, I'm going to multiply together. So 2 times 2 times 2 will give me 8, and the 7 stays underneath the square root. Bless you. Okay, the next one, I'm going to also break down. It's 891, rather large here. Now, I'm going to use my divisibility rules on this one because I can see it's not even. So I'm going to add 8 plus 9 plus 1, and I get 18. So right there, I know I can divide 891 by 3, and I can also divide it by 9. So I'm going to do 9. So I know that 9 will go on into this. Let's try and divide it out. Let's divide this. I know it'll go in there because of my divisibility rule, but I'm going to go ahead and divide it. So 9 won't go into 8. But it'll go in here 9 times. So I can say that it's going to be 9 and 81, 8, 1, 99. So I know 9 times 99 will give me 891. And again, I'm going to keep breaking it down. And these are under radicals still. So 3 times 3, 9 times 11, 3 times 3 comes straight down, and then the 9 also goes into a 3 times 3, and then the 11. So again, make a pair, make a pair. One of the pairs comes out, the 11 stays underneath. So 3 times 3 is 9, square root of 11. Now, if you're really good at finding the biggest perfect square, like this could have also been done with 81 times 11, and then if you realize the 81 was a perfect square, you square root it and you leave the 11 behind. So whatever method's gonna be the best for you, again, I highly recommend you memorize these perfect squares. Now the next part is just telling you where you could place these on a number line. So again, the non-perfect squares, you should be aware that they can be graphed on a number line. So if you, for example, know the perfect squares, like 1 times 1 is 1, 2 times 2 is 4, and 3 squared is 9. So when you go to graph these radicals, so let's say you wanted to graph the square root of 3, you can see that on your number line, it's going to be graphed somewhere in between 1 and 2. So that's what they're showing you in that paragraph there, that it's probably closer to the 4 than it would be to the 1. And we're going to be approximating some of these decimals. But what will happen when you take geometry next year is they're going to ask you to leave your answers in simplest radical form, which were the 4 examples that I did prior to this. So generally, they're not going to ask you to approximate it to the nearest decimal. But I'll go ahead and maybe show you an example of that. For example, the 684, or let's just do a smaller one. So let's say it's the square root of 26. So what you're going to do is look for the 2 perfect squares on either side, and that's going to be 25 and 36. So the square root of 25 is 5, and the square root of 36 is 6. And then what you're going to do is you're going to round to the nearest tenths place, and you're going to say, what will this approximate to? It's closer to the 25. So I would say this is probably about 5.1 or 5.2, somewhere right around in there. It's not as close to the 6. However, when you're doing the homework tonight, you're leaving all of your answers in simplest radical form. You're not going to have to approximate anything to a decimal. So that is lesson 11. You do have homework on it. Again, it's 1 through 30, and you're doing all of them. And again, you're simplifying here. We're not turning them into decimals. We're just going to put it into simplest radical form. So let's go ahead and also take a look at 11.5, because it sort of goes hand in hand with this lesson. The only difference is we're going to now have variables under the square root symbol.